We're having a look at practice question set number 7. And you can see to start off this practice question set, we've got a page of information. We know the strategy that we follow when we see a page of information like this is skim it, right? Don't read it in detail, skim it. Get a general idea as to what's going on, and then go and read the question or the questions that go with it, and then go back and read it in a little bit more detail. That gives you a general idea as to what's going on. Then we read the questions, then we go back and we know what we're looking for now in details once we read the questions, all right? So let's pretend that we skimmed through this page of information here. Now let's go to our question. Question 1 says, when it touches the generator, the metal sphere becomes blank charged as a result of the transfer of blank. So what's happening here? The metal sphere touches the dome of the Van de Graaff generator. We want to know what charge the metal sphere attains. It says the metal sphere was neutral and the Van de Graaff generator was positive, which is unusual because a typical Van de Graaff generator would be negative. That's okay. It's not a big deal, but we've got to be aware of what it says, right? R to Q, A to Q. Read the question. Answer the question. It was positive. So if we touch the neutral metal sphere against the positively charged dome, then what's going to happen to this neutral metal sphere? Neutral and positive both become positive. Yeah, positive and positive. Now, they'd like to balance out. They try to balance out. Are they going to balance out here? If the sphere was 0 and the dome of the Van de Graaff generator was plus 10, they're not going to balance out to be plus 5 and plus 5, right? Maybe it's plus 2 and plus 8. Maybe it's plus 1 and plus 9. They're probably not going to balance because of the different size of this, right? The dome of the Van de Graaff generator is going to hold more charge. That doesn't matter for this question. All we need to know is that the metal sphere becomes positive as a result of touching something that's positive. By the way, we call that charging by what? Induction or conduction? That's not really a part of this practice question set. It's part of the next one, but since you know that stuff, you can answer it. This would be charging by what? Conduction, yeah, because it's a transfer of charge taking place. All right. It's a result of the transfer of what? Electrons or protons? It's electrons. Always got to be electrons that are transferring there. So the answer is C for that one. 2. Use the following information to answer the next question. 3 identical spheres, 1, 2, and 3, have charges plus 4, minus 2, and minus 4 microcoulombs. That's not really a big deal. But you guys know that a microcoulomb is 10 to the minus 6 coulombs. Pairs of spheres are brought into brief contact with each other without grounding and then separated in the following order. 1 touches 2, then 2 touches 3, then 1 touches 3. This is one we got to make a table for, right? Charge 1, charge 2, charge 3. Initially, 1 is plus 4 microcoulombs, 2 is minus 2 microcoulombs, and minus 4 microcoulombs. Now the total charge, let's create a separate column there for the total charge. We don't really need that, but it just helps us to kind of keep track of whether we're on the right track or not, right? If we end up finding the total charge at every step along the way, and we find that it's different than the last one, then we know that we've made a mistake somewhere along the line. Okay, what's the total charge here? Plus 4, plus 2, minus 4 gives me a total charge of minus 2. Right. Now the total charge has to remain minus 2 throughout this whole problem. Now, it says 1 touches 2. 1 touches 2. Plus 4 and minus 2. Let's assume that these things are going to balance out, because that's the only hope we have of answering this question, is if they do balance out. Plus 4 and minus 2 become what and what? 2 and 2? Careful. 4 and negative 2 gives me 2. But then we have to split it up, so it's going to be plus 1 and plus 1. Does that make sense? So we're going to say plus 1, minus 4. Let's add these up just to make sure that we still have minus 2. Plus 1, minus 4 gives me, sure enough, minus 2. All right. Now the next one says 2 touches 3. 2 touches 3 now. Plus 1 and minus 4 become what? Plus 1 minus 4, well, that's minus 3 divided by 2 gives me 1.5, yeah, minus 1.5. Minus 1.5, minus 1.5, and this one's going to give me plus 1. Let's just double check, make sure we're on the right track here by adding up my charge to make sure that we get a total of minus 2. Minus 1 minus, or plus 1 minus 1.5 minus 1.5 gives me minus 2, sure enough. Good, so far so good. Now we got 1 and 3. 1 and 3 are going to touch each other. 1 and minus 1.5. That's negative 0.5 divided by 2 is negative 0.25. And this one remains negative 1.5. Let's add these up just to make sure that we still get minus 2. Minus 0.25, minus 0.5, minus 0.25, sure enough, gives me minus 2. So am I good? Looks like I've done them right then, right? Like odds are I've done them right. The final charge on sphere 1 is going to be minus 0.25. Don't forget that it's microcoulombs. Okay, how many people got that? Good. And finally, question number 3. The number of excess electrons on a ball that has a charge of minus 3.6 times 10 to the minus 17 is what? You guys remember how to find the number of the electrons? Sean, what is it? Yeah, the total charge, 3.6 times 10 to the minus 17, divided by the charge of one electron, which is 1.6 times 10 to the minus 19, on our data sheet, right? Now, if we do that, we get 225. Now, we're asked to express it in scientific notation, so we'll make that 2.25 times 10 to the 2. And now we're asked for the values of A, B, C, and D. So we're going to say that's 225 and 2. 2252 would be our answer. Now, listen, A, B, C, D, our answer is 2252. If this was one of those B times 10 to the W's, which we see sometimes, bless you, we see that sometimes, right? B times 10 to the W. Then if that was the case, our answer would just be 2.25. Make sense? B times 10 to the W, find the value of B, 2.25. A, B, C, D, 2252. Two completely different ways of expressing the exact same answer. Just make sure you know which way you're asked to express it, that's all. Good there? Good? All right. Quiz number 7 is going to be tomorrow. Okay. Notice there wasn't any charging on this, charging by induction, charging by conduction. There wasn't any of that on this. Okay, so that won't be on tomorrow's quiz either. Just this basic electricity stuff, which is stuff that led up to the charging by induction, conduction, separation of charge, and so on. Yeah, let me say